Hello and welcome everyone. Welcome back to this channel. We are studying class 10 science chapter 12 electricity. So till the previous video we have finished all the theory topics and we have now come to the exercise question solution. So this video is the part 1 of the exercise questions because the exercise is little bit lengthy. So I have divided this into two parts. So in this video we will take up to 10 questions, right, which also includes MCQ, but MCQ solution is done by me in this video step by step, so please see carefully, right. It is related to solution of numerical, so direct answer won't be very helpful, so solution is also given. Now let us start with the first question. A piece of wire of resistance R is cut into 5 equal parts. Note that 5 equal parts. These parts are then connected in parallel. Second hint given is that they are connected in parallel. If the equivalent resistance of this combination is R dash, then the ratio R to R dash is dash. So four options are given. Directly we cannot judge that whatever is the answer. So let us try to solve this. First of all, the wire is cut into 5 equal parts, which means the resistance of each part becomes R upon 5. We know that each part is connected to each other in parallel. So how shall we write the equivalent resistance? It is 1 by R dash equals to 1 upon R by 5, 1 upon R by 5, 1 upon R by 5, 5 times. Okay. Now denominator is always going into numerator. So these all 5s that you are seeing in denominator will go into the numerator. So now the equation becomes 1 by R dash equals to 5 by R plus 5 by R plus 5 upon R plus 5 upon R plus 5 upon R. Now if you see the denominator, R is common, so we'll take R as a common denominator, LCM, and in the numerator all the 5 will be added and that will give you 25 upon R. Now in the question, if you see carefully, we have been asked ratio of R to R dash. So we will take this R over here on the other side, so it will become R by R dash. Here only 25 will remain. So this will be our answer. Okay. Moving on to question number 2. Which of the following does not represent electrical power in a circuit? Now we have already seen few formulas of power, and just if you remember the formulas, then we can know that IR square is the wrong answer. It does not represent the electrical power. But let us see again, let us revise again few formulas of electric power. Electric power is given by the expression P equals to V. Now, according to Ohm's law, V equals to IR. So, if we put in equation number 1 IR instead of V, we will get P equals to IR into I, that means I square R. So, option A is also correct. Now, similarly from Ohm's law, if we replace I as V by R, so what will be the formula? V into V by R, that means V square by R. So that means these three highlighted are already the equation of electrical power. So what left is I R square, that doesn't represent electric power in a circuit. Okay. Moving on to the third one. An electric bulb is rated 220 volt and 100 watt. So this is case number 1. When it is operated on 110 volt, the power consumed will be dash. That means this is case number 2. So let us try to find out resistance of the bulb first and then we will use it in case number 2. So case 1 is energy consumed by the appliance is P equals to VI, that means V square by R. Just now we have seen equation of power. The resistance will be R will take the left hand side, so P will go on right hand side. Now V is given in first case 220, so it will be 220 square upon P is 100 watt. So 220 square upon 100 is 484 ohm. That means in the first case power is given, voltage is given, and we have calculated R, that is resistance. Now let us apply the same concept in case number 2, but now we know about R. So let us see. If the supply voltage is reduced, instead of 220 it is now 110, but resistance is the characteristic of wire, so it will remain the same. So power consumed P equals to V square upon R. V right now it will become 110 R is 484, and that will give us answer as 25, right? So the power consumed when electric bulb operate at 110 volt is 25 volt. Moving on to fourth one. Now this is very important. You try to understand this question step by step, because there are much more concepts which are new to you. Two conducting wire of same material and an equal length and equal diameter are first connected in series and then parallel across the same potential difference. Now we have to relate the ratio of heat produced in series and parallel combination. So from resistance we have to go for the ratio of heat. Okay, now let us see the solution. Let RS and RP be the equivalent resistance. How many wires are there? Two. So if we find out Rs, if in series, so it will be R plus R 2R. Same way if we find Rp, according to the formula 1 by Rp equals to 1 by R, 1 by R, that is 2 by R. So if you do the reciprocal, Rp will be R by 2. Okay, so we have equivalent resistance of the circuit. Now for the same potential difference, ratio of heat produced in the circuit is given. See, heat produced when the wires are in series. So power into time, heat is power into time, P into T. P is equal to VI, that we have seen earlier. So P into T is V into I into T. What is I as per Ohm's law? It is V by R. So final equation of heat produced in series connection is V square upon Rs into T. Clear? This is the equation of heat produced when the series connection of wires is there. Now same way can we find for parallel? So it will be Hp equals to V square upon Rp into T. Now very simple. We have been asked about ratio of heat produced. So now what we will do? Hs upon Hp. So Hs is V square by Rs into T and Hp is V square by Rp into T. See now, V square will be cancelled, T and T will be cancelled, this Rp will go upside and this Rs will go down. So ultimately, heat produced ratio is ratio of the resistance. So Rp is R by 2, Rs is 2R, R again cancelled. In the numerator we have 1, denominator we have 2 2s are 4. So option C is correct. Okay. This was a very lengthy question. I have tried to reduce it in a very short manner so you can understand. Right? Moving on to the next question. How is a voltmeter connected in the circuit to measure the potential difference between 2 points? We all know that to measure the voltage between any 2 points, voltmeter should be connected in parallel between the 2 points. You can see this, right? Voltmeter is always connected parallel. So this was an easy question. Moving on to the next one. A copper wire has diameter 0.5 millimeter, resistivity is 1.6 into 10 to minus 8 ohm meter. What will be the length of this wire to make its resistance 10 ohm? How much does the resistance change if the diameter is doubled? Now, this question right now if you see will appear very tough. But if I say that we are using only one formula of resistivity, then it will appear very easy. Now you know what is the formula of resistivity or resistance and resistivity formula we have seen. R equals to rho L by A, right? Area, you all know what is area of cross section. It is circular, so it is pi r square. Now is the radius given? No, not given. Diameter is given. So instead of pi r square, we will write pi d by 2 whole square, because ultimately d by 2 is nothing but radius only, right? Now we have been asked what will be the length. So from this formula, if you can make a formula of L, so what it will be? This will be the formula. L equals to RA upon rho. Now, do we have the value of R? Yes, it has said that resistance must be 10 ohm. So we'll write 10. Okay. Area is pi into d by 2 square. So pi is 3.14 into d is 0.0005. Why 0.0005? Because here it is given in millimeter, but now we have to convert it into meter. So 0.0005 square upon 2. That will be the pi r square area upon resistivity is already given 1.6 into 10 to the minus 8. So basically what you did is just you put all the values as per the units, and if you calculate it properly it will be 122.72 meter. Okay, so this is our first answer. Just one formula we have used. Now the second question is how much does the resistance change if the diameter is doubled? Okay, so now if we double the diameter it will be 0.5 mm into 2, that means 1 millimeter, and 1 millimeter is 0.001 meter. So now let us find out the resistance, that is rho L by A. Rho value is already given, L we are already counted 122.72 upon area is pi r square. Now again we don't have r but d, new number we have 0.001. So 0.001 by 2 whole square will be the area, and overall the right answer that you will be getting after simplification is 2.5, right? So resistance finally will be 2.5 ohm. Again I am telling, if you feel that this is very lengthy kind of question, don't forget that we have used only one formula, right? So you must be smart enough to find out that everything is given except one. How you will use the formula in that and how you will find the answer depends on your smartness. Moving on. Now question number 7, we have the values of current I flowing in a given resistor for the corresponding values of potential difference V across the resistor. So in short, we have been given a table of I and V. We have to plot a graph between V and I and then calculate the resistance graphically, right? So graphically, if you want to find out the resistance based on V and I, you just have to find the slope. Let us see how the graph becomes when we plot this. So the graph is like this. If you see, x-axis voltage and y-axis current, and based on all the points given, I have plotted a graph right now over here. Let us select 2 points A and B and try to find out the slope. So for finding the slope we just have to complete the triangle, right? So we have drawn parallel lines, perpendicular lines A, B and C completing the triangle. Now the slope of this line will give the value of resistance. How is the slope calculated? So it is AC, this is AC, that is the voltage, upon current. Okay, V by I. So where is the voltage? It is shown by AC. And where is the current? BC. So what is the resistance as per Ohm's law? R equals to V upon I, that is AC upon BC. That is 6.8 by 2, and final answer we are getting is 3.4 ohm. So this was very easy unless you draw a proper graph. Moving on to the next question. When a 12-volt battery is connected across an unknown resistor, you see what we are finding? The unknown thing, that is resistance. The current of 2.5 milliampere in the circuit, right? So voltage is given, current is given, you just have to find out resistance. Which formula we will be using? Ohm's law. So the value of resistor will be calculated using Ohm's law. R equals to V upon I. V is 12, but what is current? Milliampere. So to convert milliampere into ampere, just multiply it to 10 raised to minus 3. That means 2.5 into 10 raised to minus 3 ampere. Okay. 10 raised to minus 3 will go upside. 12 upon 2.5 will be 4.8. So again, very simple answer. The resistance is 4.8 into 10 raised to 3 ohm. Next question, again very easy. Battery of 9 volt is connected in series with 5 resistors, 0.2, 0.3, 0.4, 0.5 and 12 ohm resistors. How much current would flow through the 12 ohm resistor? Now don't forget the very basic concept. In series connection there is no division of current. So even if there are 5 different resistors, current will be the same. The current flowing across all the resistors is the same. So total resistance, let us find out by using Ohm's law. For that we need total resistance. Add all the resistance, you will get 13.4 ohm. Now utilize Ohm's law. I equals to V by R. We are finding I. So what is V? 9. What is R? 13.4. So 9 upon 13.4 is 0.67. That will be the current flowing in the circuit. Okay, see, only Ohm's law we have utilized. Moving on to the last question of this video. Again, very important question, a tricky question I must say. How many 176 ohm resistors in parallel are required to carry 5 ampere on 220 volt line? So this is a kind of challenge, mind trick. Let us consider that we need n number of resistors, each having the resistance 176 ohm. Okay, now we have to connect them into parallel. So how shall be the equivalent resistance, overall equivalent resistance, right? If there are two resistors, 1 by 176, 1 by 176. If there are three, 1 upon 176 plus 1 by 176 plus 1 by 176. If it is more than 3, we will multiply that with that number. So if it is n number, what will be the equivalent resistance? 1 by r equals to n into 1 by 176. Okay. So ultimately the equivalent resistance we have got, right? Now current is 5 ampere, voltage is 220. So by Ohm's law, R equals to V by I. Here R we have calculated 176 by N. According to Ohm's law, we can find R as V by I. Is V and I given? Yes. So leave all this. We can find R by using V upon I. What is that? V upon I is 220 upon 5, and 220 upon 5 is equal to 176 by n. We are just comparing both the equation. You see, both are r only. So 176 by n equals to v by I. That will be 176 by n equals to 220 by 5. If you want to find out n, you have to take this n on other side, and 5 and 220 will be the reciprocal. So ultimately it is 176 into 5 upon 220. The answer will be 4. That means we have to join 4 resistors of each 176 ohm in parallel to get this current 5 ampere on 220 volt. Clear? So again, nothing new, just the concept of equivalent resistance in parallel connection and Ohm's law, comparing both the equation and getting the answer. Now that's it for this video. We have seen 1 to 10 question. Few of the questions this year are not in the GSCB course. So if you don't want to write, that depends on you. But I suggest that if we have studied all the concept in the theoretical videos, you must write all the questions as a part of your notes, right? Reduce syllabus you study for the board exam, but till now, whatever we have studied fully. So complete everything in your notebook. That's it for today. Thank you.